Hey, this is Alex from RF Venue. This is part one of our three-part quick start guide on using Clearwave's frequency coordination software for the RF Explorer Rack Pro. I'm going to go over how Clearwaves is organized and how to make and interpret your first spectrum scan. If you don't already have Clearwaves installed, you can download a free copy by going to www.rfvenue.com/clearwaves. If you bought a Rack Pro, it came with a license key. Use that key to activate the software and please don't lose it. When you first open Clearwaves, you'll be greeted with this screen. An empty graph with no scan and what might look like an intimidating number of choices and tools. It's not really that complicated, especially because unless you're doing some serious RF coordination with hundreds of devices, you really only need 3 of these features. The scan feature, which we're on now, the intermodulation calculation feature, which creates perfectly coordinated sets of frequencies based on the spectrum around you, and the monitoring feature, which alarms frequencies you specify for dropouts. Let's start by getting a simple scan. The first thing you'll want to do is define your range, the highest and lowest frequency that the Rack Pro will scan. I've chosen arbitrary values here between 550 and 580 megahertz, but if you're using a specific make and model of microphone, or IEM, you'll want to enter the range specified by the manufacturer. For example, let's say you're using a Shure ULXD microphone or multiple microphones in block L50. You'd set your range between 632 and 696 megahertz. Once you've got your range set up, head on over to the Start button and click. The scan will initialize. Depending on the speed of your processor, it may take less or more time. The smaller your scan range, the faster the scan will refresh. The larger the range, the longer. Okay, here we go. This is a visualization of the radio spectrum between 550 and 580 megahertz. The x-axis on the graph represents frequency. Each interval or step along this axis is progressively higher in frequency. The y-axis is the strength or amplitude of any given frequency at the Rack Pro's location. If this doesn't make sense, we can try looking at it in a different way. The RF Explorer has a lot in common with your wireless microphone receiver. It senses the frequency and amplitude of a given radio wave, which is what the signal meter indicator on the front of your receiver is doing. But instead of displaying just one frequency, the Rack Pro is displaying many. You might think of the Rack Pro as if you're looking at thousands of signal meters on thousands of receivers at the same time, all lined up next to one another, each tuned to a slightly higher frequency than the last. The cumulative picture of all these meters lined up next to one another is a spectrum scan. The jagged line that you see is the software visually tracing along the peaks of each signal meter. The cumulative effect is something that looks like the outline of a mountain range. The peaks are where there's a concentration of frequencies that the Rack Pro senses as having high amplitudes, and the valleys are where the Rack Pro sees low RF energy. As a general rule, the areas of the scan which appear to be lower, the valleys, if you will, are where the noise floor and number of competing signals are low. The areas of the scan that are higher in amplitude represent areas of the spectrum that contains lots of noise or many strong competing signals. These are areas you want to stay out of. For example, this plateau here is most likely a nearby digital television station, so you want to stay out of there. And you want to place microphones where there is as low a noise floor as possible, like maybe over here. You'll notice there are a bunch of very enticing tabs at the bottom. These can be very useful to experienced RF technicians and engineers, but for run-of-the-mill wireless audio device coordination, they simply are not necessary, and I'm not going to talk about them here. If you're using just 1 or 2 microphones, you can do a simple scan, just like this, and visually locate areas of spectrum that have a low noise floor and are free of competing signals. read the values labeled on the x-axis, or when hovering over the graph, view the readout of what the frequency is, and then simply choose a frequency in that general range. But if you're using 3 or more microphones, you need to be more careful and use the intermodulation analysis feature that Clearwaves provides to avoid having the microphones interfere with one another. More on that in the next video. See you soon.